Welcome to class today. Today I'll be talking about certain topics that have occurred over the years in your NECO Chemistry essay. So this revision, I'll be dealing with topics including electrolysis. How do you determine the amount of a particular substance that is deposited at the anode, at the cathode? There's a calculation aspect of it, which is the second law of Faraday's law of electrolysis. How to calculate the amount of or the mass of substance that is deposited. I'll be talking about the reactions that occur at the anode, at the cathode. Remind you, I'm giving you shortcuts that you can quickly use and you can remember in the exam hall, and then they will help you. I will be talking about what kind of reaction occurs at the anode, at the cathode, how to determine preferential discharge, what will be discharged at the anode, which ion will be discharged at the cathode. I'll be talking about stoichiometry, which is mole concept, acid-base reaction, titration reactions. It's also going to come out in your essay as well. You'll be asked to calculate molarity, molar concentration, and all of that. I'll be talking about acid, bases, and salts. So stick around to the end of this video and I will show you shortcuts you can use to remember all of this in your exams without having to cry. I will talk about solubility, and I will talk about the periodic table. I will talk about periodicity, how to know how properties increase across the period down the group. I'm talking about shortcuts that you can use to know ionization energy, electron affinity, atomic radius, ionic radius. I'll talk about all of that. So please stick around to the end of this video. If you have not subscribed to our channel, do well to subscribe to our channel right now as we go into this class. Welcome to class. Here is a question on the board. The question says calculate the mass of copper deposited. So we are looking for mass is unknown. Mass of copper deposited at the cathode when a current of, so our current is 0.2 ampere, is passed through a solution of copper 2 tetrasulfate 6. Copper CuSO4. So if you ionize this, going to give you copper 2 plus SO4 2 minus. So the charge that we're going to be using for this calculation is plus 2. So our N is plus 2. All right. When a current of 0.2 ampere is passed through copper sulfate for 35 minutes. So the time is 35 minutes. But we are not going to use minutes. We're going to convert to seconds. That's the SI unit of time. So we are multiplying 35 by 60, and that's going to give us the number in seconds. Mind you, if it is hours, you multiply by 60 times 60. But if it's minutes, you multiply by just 60 only once. Multiply by 60, and then what other parameters were given? The molar mass of copper is 64. So our relative atomic mass of copper is 64, and then 1 Faraday is 96,500 coulombs. And of course we were given the different molar masses, which of course is not necessary. You don't need to calculate. So some students will go ahead calculating the molar mass of copper sulfate. You actually do not need that, right? You only need the relative atomic mass of copper, which you are being given. So if we are going to convert this to seconds, you have 350 by 6. That is 30, 80, 921 to 2100 seconds, 2100 seconds. Okay, so what formula is the short formula that you can use to answer this question? The formula is very simple. Now, if you have ever been to a mosque, okay, when you enter into a mosque, you see that the men are sitting towards the front part, and then there is a wall. And then you have the women are sitting at the back, and in front of the men you have the person teaching them, the priest or the imam teaching them, and then he has a Quran, that's the holy book that he uses to teach them. Now, what has that illustration got to do with chemistry? Very simple. So what we are going to be learning from that arrangement in the mosque, we are going to use it in chemistry. And the formula we're using is that when you get to a mosque, you see a Quran, you see a wall, you see number of females. I'm going to break this down for you right now. So that frontal part where you are seeing men, and then you are seeing the priest, and you are seeing a Quran. So the priest, the imam, is holding a Quran. So you have the Q-ram. So here not Q-ram but Q-ram. Okay, you see a wall, then you see the number of females sitting at the back. So what has this got to do with? Our M is the mass that we are asked to calculate. Our Q is the quantity of charge, and the formula for quantity of charge, Q equals IT, according to the first Faraday's law of electrolysis. Okay, Q equals IT. So you are going, for you to get your Q, you are going to multiply your current by the time in seconds. Okay, and then our RAM is the relative atomic mass, our N is the charge, which is +2, our F is 96,500. So by the time you impute all of those values, you are going to get the mass that you were asked to find straight up. So let's try that. Our Q is going to be what? Current is 0.2 amperes times time. The time is 2100. So this, we cancel this by 1. So I'm going to have 420 coulombs. 420, the quantity of electricity is 420 coulombs. So let's slot in the value. Our M is going to be, our Q is 420 multiplied by the RAM is 64 divided by the N is 2 multiplied by 96,500. So if you punch your calculator, what is it going to give to us? Multiply 420 by 64, you have 26,880. 2 by 96,500 gives you 193,000. So if you divide it, you are going to have 0.139 grams of copper, or approximately 0.14 grams of copper. So that is the amount of copper that has been deposited at the cathode here. So all you need to do is to master this formula and know what your Q is. Your Q is IT. You know what your relative atomic mass is. Know what the charge is. Know what your F is, and then slot in the values. You get it straight up. All right. So I can actually guarantee you that there is likely going to be a question on this calculation, but no matter what, there must be a question on electrolysis in your exams. Now, before I go to the next topic, let's talk about how. So we have done amounts deposited. Let's try to know reactions that occur at the anode, what occurs at the cathode, then preferential discharge. Let us see. Then we want to know the reactions that occur at the anode and cathode. The first thing you need to know, what is anode? What is cathode? Then what is anion? What is cation? They can ask you to explain any of them. The anode is the positive electrode. Anode is positive electrode. Anode is the positive electrode. Cathode is the negative electrode. And what are electrodes? Electrodes are the gateway. They are the parts. They are the conductors. So they are metals. They are conductors through which current enters and exits the electrolytic circuit or setup. Electrolytic setup. Okay? They are rods or conductors through which current enters and exits electrolytic cell. Better still. So negative electron. Anions are the anode ion. So anion simply means anode ion. What's the meaning of anode ion? Those are the ions that will migrate towards the anode, which are positive electrode. So these ions, and you remember like poles repel or like poles attract. So the kind of ions that will migrate towards the anode will be negatively charged. So example of anions are your OH minus, your SO4 minus, Cl minus, etc. These are examples of the ions that will migrate to the anode. Then the cations are the cathode ions. Cathode ions. What are cathode ions? They are you remember cathode is the negative electrode. All right. So that means negative ions cannot move to the negative electrode. It is the positive ions that will go there. So these are positive ions. So cations are positive ions. Positive ions, e.g. H plus, Cu2 plus, Mg2 plus, etc. Those are the ions that moves towards the positive one. Now, so what occurs at the anode? I'm going to give you an acronym right now, or a mnemonics right now that you can use to remember all of these. So the first I'll be talking about is panic. What is panic? Panic means positive anode, negative is cathode. Positive anode, So positive anode, the negative is cathode. So use that to remember these. All right. Then the next one I will talk about is anox. What is the meaning of anox? Anox means the anode is where oxidation occurs. So at the anode is where oxidation occurs. The next acronym is CARE. C-A-R-E, CARE. Or you can say red cat. Red cat. What is the meaning of red cat? Red cat means reduction occurs at the cathode. Reduction at cathode. Or if care, you can say care. Care means at the cathode reduction occurs. At the cathode reduction occurs. So that is that. Anox, panic, red cat. The next one I will talk about. So when they ask you to determine what happens at the anode and the cathode, and you are telling them at the anode oxidation occurs, what is the meaning of that oxidation? Is it that electrons will be lost there or electrons will be gained? We are going to look at that right now. I'm giving you another shortcut to do that. Next thing is, we've done the anode, the cathode. So I said I'm going to give you an acronym how to know what that oxidation is. So the next mnemonics is oil rig. What is oil rig? Oil rig means oxidation is loss, reduction is gain of electron. So oxidation simply means what? Loss of electron. Then reduction is gain of electron. So when you say oxidation occurs at the anode, that means electrons are lost at the anode. So oxidation, so here for this anode I'll say oxidation occurs here, which is loss of electron. So if they ask you to define or talk about the anode, they explain what happens there, that's what you do. While at the cathode, reduction occurs here. Reduction occurs here. And what is that reduction? Reduction is gaining of electron. That is gain of electrons. Now, after all, having understood all of this, the next thing is let's determine how to determine preferential discharge. So now, let me give you an example, a small setup, typical electrolytic cell setup. Let us see what occurs inside the cell. So before I continue, what is electrolysis? So electrolysis, if you could be asked to define, is simply the what? Is the chemical decomposition of a chemical compound, the chemical decomposition of a compound when direct current flows through it. It is the chemical decomposition of a compound when direct current flows through it. So this is an example of an electrolytic setup. You've seen a car battery before. You see that there are two rods on the head of the car battery. These are the rods. Those rods are the electrodes. So this is an electrolytic setup. Inside here you have an electrolyte. All right. So that liquid that is inside here, that's the electrolyte. And that electrolyte is the compound that will be broken down. So let me tell you the concept behind electrolysis. If you look at your salt in the kitchen, your table salt, what's the chemical formula of your table salt? It's sodium chloride. Sodium chloride. So if somebody tells you to separate the salt into sodium and chlorine, well, how would you do it? You would have to scoop a little of the salt and start doing hand picking. Can you do that? Can you use hand picking to separate sodium and chlorine into sodium and chlorine? No, you can't. But the method that you can use to separate this compound into the ions, which are sodium and chlorine ions, the method is electrolysis. So electrolysis will decompose. It will split this compound into ions when direct current passes through it. All right. So if inside there, so let's say this sodium chloride is the electrolyte. The electrolyte is the compound that will be decomposed. All right. And then these are the electrodes. So if this is the positive, it is the anode. Then this is the negative. This is the cathode. And of course, I have sodium chloride inside here. Sodium chloride. Now, this definition is not yet complete. It's the chemical decomposition of a compound when direct current flows through it in its aqueous or molten state. Please add that to your definition. So not just that it's going to decompose, but it has to be in its aqueous or molten state. What's the meaning of molten state? What's the meaning of aqueous? Molten is from the word to melt. When candle melts, you have the molten wax of candle. All right? Now that is different from when you have salt. If I pour salt into water, I'm mixing the salt and the water. Those are two compounds. If I mix it, then I have salt solution. That solution is an aqueous solution. So when they say in its aqueous or molten state, the aqueous is the aqueous solution. The molten is where you melt it. It's important to add that to your definition, and it's important to know the difference between the two. Now, let's talk about the, we now ask you, what occurs at the anode, what occurs at the cathode? Mind you, look at the question very well. If it is in molten state, I told you molten means melted. So if it's in molten state, that means it is just sodium chloride. So we are using sodium chloride as an example. In molten state, you only have this compound, sodium chloride, which we split into Na plus Cl minus. So because there are only these two ions, the sodium ion, Na plus, will migrate to the negative cathode, to this cathode. So your Na, all right, will be the one to migrate here. While your Cl minus will migrate to this point. Your Cl minus will come here, migrate here. What is it coming here to do? What is your Na plus coming here to do? That's another question they can ask you. Your Cl minus, so the meaning of Cl minus, this minus signifies or indicates that it has extra electrons on it. Na plus signifies that it has shortage of electrons. So look at this. In this setup, electrons are coming in and going out. So this setup is usually connected to a battery. That's why they said when direct current flows through. So this is a battery, and that's DC. The current you get from a battery is direct current. The one you get from your power source, which is your power supply, that is AC. All right. So this is a DC. When you connect direct current to this, passes current. So electrons are entering and going out. Currents are also coming in and going out. So the next thing is, where does current come in through? Where does electron come into? Now take note of this. Electric current and electrons move in opposite direction. Let me repeat that. The conventional current and electrons move in opposite direction. So if current is moving forward, electrons are moving backward. The meaning of that is, wherever current is coming in through here, that exact point is where the electrons are exiting through. So here, where does electron come in through? Those are some questions they can ask you. Electrons come in through the negative gate of this setup. What's the negative gate? These are the two gates through which current leaves and exits. This cathode is the negative gate, and that is where negativity enters this system. And you remember, electrons are negatively charged. So negativity, E minus, is entering through here from this battery source. So current, if this electron enters through the cathode and then it comes out here. So here, electrons are going out. While the current, conventional current, is coming in the opposite direction. So here, current is coming in and current is exiting here. So this is current flowing out here. Current coming in here. Are you seeing now? So electrons are flowing out here, currents are coming in here. So what is this chlorine coming here to do? So this Cl minus means it's carrying an excess chlorine or excess electron. So it will come here to deposit the electron. You remember this is the gate through which electron exits. Electrons are coming out. So this guy is coming here to deposit electron so that the electron can go out. Why this Na plus means there's a shortage of electron but excess of proton, positive proton. So it's coming here to come and tap electrons that are coming in. Look at how electrons are coming in. See, coming in. So Na plus is coming here to tap the electrons. Now that accepting of electron or gaining of electron is what we call what? Look at it. Reduction at the cathode. And we said reduction is gaining. Reduction is gaining. So that is why reduction is occurring here. Sodium is coming here to gain electron. Oxidation is lost. Chlorine is coming here to lose or give out electrons so that the electrons can pass out of the system. So that is actually what occurs here. So when we say in molten states, we are just talking about sodium and chlorine, and there are two ions. But when the question says in aqueous solution, I told you solution means the sodium chloride has dissolved in water. Now, but when this sodium chloride is in aqueous solution, that means there is also H2O. H2O. So if you ionize sodium chloride, you have Na plus, Cl minus, H2O we ionize to give you H plus, OH minus. That means when the question says in an aqueous solution, which one will be discharged at the anode? Which one will be discharged at the cathode? That means we have four options. Unlike the molten where we had only two, and it was easy to just say Na plus goes to the negative, this goes to. But when you have four options, how do you, and out of these two, only one will be discharged. Out of these two, only one will be discharged. And that is where the challenge is. So they can ask you which one will be discharged at the anode, which one will be discharged at the cathode. So you are expected to know how to determine it. So the first thing you want to do is this. I'm going to give you a shortcut. So there are three factors that determine. Number one is the position of an ion on the electrochemical series. All right, position on the electrochemical series, and that is usually used for the electropositive ions. And that property says for electropositive ions or electropositive ions that are high, that have high electropositivity, it states that the ions that are lower in the series will be preferentially discharged to the ones that are higher in the series. So I'm going to give you another shortcut you can use to know the series, the electrochemical series right now. I'm going to give you that. But the ones that are lower in the series will be preferentially discharged compared to the one that is higher. So sodium and hydrogen, which one is lower in the series? That brings us to the knowledge of the electrochemical series. So let me quickly give you another shortcut you can use to know the electrochemical series. Come with me. Determine which ion will be preferentially discharged, you need to know the electrochemical series. So the electrochemical series for the electropositive ions, the arrangement is, so you can use this mnemonics. Please stop calling me a zebra. I truly like him calling me super powerful giraffe. So what as all of these, what do they stand for? Please means potassium. So potassium ion is the most electropositive ion, right? Sodium, potassium, sodium, calcium, magnesium, aluminium, then zinc ion. This is iron, this is tin, this is lead, this is hydrogen ion, then this is copper ion, then this is mercury, this is silver, and this is platinum, and G is gold. So this order, if I draw a line like this, this is the order of increasing electropositivity. electropositivity. So that means this is the most electropositive, this is the least electropositive, while this is the order of discharge. So increasing order of discharge. So the increasing order of discharge is downward. That means this is higher. So areas that are lower in the series compared to those that are higher will be discharged. So we are looking at sodium and hydrogen. Look at it, sodium and hydrogen ion. Look at sodium ion here, Na plus. But look at hydrogen here, H plus. So hydrogen is lower in the series compared to sodium. Therefore, hydrogen will be discharged. Because hydrogen will be discharged, so hydrogen will be the one to move to the negative cathode, while the sodium will remain in the solution, right? So that is what you do for the electropositive ions. Then the second factor is the nature of the electrode. The nature of the electrode can determine who will be discharged. For example, when you are using copper electrode in copper sulfate ion, all right, the copper in the compound, copper sulfate compound, okay, that copper can be influenced to move because the nature of the electrode is copper electrode, because the electrode is copper electrode, to influence which ion will be discharged. So copper will naturally move out of that solution because of the presence of copper electrode. If it is sodium and mercury, if you are using a mercury electrode, there is a reaction between sodium and mercury that is called sodium amalgam. Okay, sodium amalgam. Now, once once in the compound you have sodium there, and you are using mercury electrode, the mercury will attract the sodium. So the nature of the electrode can influence the decision. And finally, the concentration gradient of the compound. So when the reaction is, let's say brine, for example, brine is concentrated sodium chloride, and then there is also sodium chloride solution, dilute solution of sodium chloride. So the outcome will not be exactly the same. All right, so concentration also matters. So if you want more details on this topic of electrolysis, I have a video on my channel that I've done on electrolysis. I've broken it down with several examples. I will also drop the link to the video in the description in this video, so you can check it out. So, but for your negative ions, how do you know what is discharge? So the first thing for this negative ions, now they are to move to the anode. So to determine the preference of the anode, so preferential discharge at anode, discharge at anode. How do you determine? The first thing you look out for is presence of halogen. So is there an halogen in the option? So you remember we did sodium chloride and water. So at this point we have OH minus and chlorine. Is there an halogen here? Yes, chlorine is there. Halogens are group 7 elements. So when there is an halogen in the option, it is that halogen that will be discharged. So here chlorine will be discharged. So presence of halogen. So halogen will be discharged. But in the absence of halogen, when there is no halogen, for example, if you are dealing with SO42 minus in water, now here there is no halogen in these two options. So who will be discharged? The rule says if there is no halogen, then it is your OH minus that must be discharged. And that OH minus will lead to the release of oxygen gas. So in the absence of halogen, OH minus will be discharged, leading to release of oxygen gas, liberation of oxygen gas. So you are going to have a reaction like this: OH minus liberating water, 2H2O plus oxygen gas. All right, 4 of these. So if you look at this equation, oxygen on this side, there are 2 and 4 oxygen, 4 hydrogen, 4. So this equation is balanced. So this is what occurs at the anode. This OH minus will migrate to the anode and this reaction will occur. And you remember we said oxidation always occurs at the anode. So OH minus is having oxidation number of -1. Absence of halogen, OH minus will be discharged, leading to the release of oxygen gas. So this is the reaction. This OH minus will go to the anode and this reaction will occur. So at the end, it's going to give us 4 moles of OH minus, 2H2O, and this. How many oxygen are here? 4. How many here? 2 plus 2, 4. How many hydrogen here? 4. How many hydrogen? 4. Equation is balanced. So this is what we are occur at the anode. You remember we said at the anode oxidation occurs. So how has oxidation occurred here? Oxidation number here is minus for oxygen. All right, the sum of oxidation of everybody here is minus. But by the time you got here, oxidation of oxygen is now 0. So from minus to 0, that's an increase in oxidation number. So it has increased from -2 to 0. That increase in oxidation number is also called oxidation. And with that, we have been able to complete the amount of electrolysis, amount deposited, reaction at the anode and cathode, then preferential discharge. The next thing I'll be talking about is stoichiometry. I'll talk about acid, base, and salt. I'll talk about solubility and periodicity. Now, wherever this video ends, you can check for the part 2 of the video so that you can have access to the rest of the discussions in this revision class. All right, come with me. The next topic we talk about is stoichiometry, more concept. I want to give you very quickly 5 equations that you would use to answer any question in your mole concept. I'll give you those 5 formulas, master them, very simple, short formulas, and then we take an example and look at it. Number 1 is number of mole equals to mass over molar mass. Your mass in gram, molar mass in gram per mole, number of mole in mole. Number 2, number of mole equals to molar concentration times volume, and the volume has to be in dm cube. This molar concentration is concentration in mole per dm cube. Your number of mole is still mole. This second formula is also called N equals CV. You can replace it with N is number of mole equals C, molar concentration, times V, volume in dm cube. Number 3, molar concentration is equals to mass concentration over molar mass. The SI unit for molar concentration is concentration in mole per dm cube, or you can call it molarity. Molarity. Okay? Molarity. Either of the 2 is correct. Molarity. Okay? Then your mass concentration is in gram per dm cube. Your molar mass is gram per mole. Then the 4th equation is 1 mole of a substance is equals to 6.02 times 10 raised to 23 atoms or molecules or ions. They can ask you to calculate the number of ions. And number 5, 1 mole of a gas at STP equals to 22.4 dm cube by volume. Meaning the volume of 1 mole of a gas at STP is 22.4 dm cube by volume. STP means standard temperature and pressure. And these last 2 equations are called the Avogadro's constant. Avogadro's constant. Avogadro's constant. Now, mind you, if you can master this, you can also use this formula to solve questions on solubility. Okay, yes, you can. So this specific equation, this equation, and this equation, these 2 equations can be combined to give you the formula you're going to use for solubility. So you need to master these. So now let's see example of how questions come, and now you can apply this to answer the questions. This question says calculate the amount of hydrochloric acid in 40 cm cube of 0.4 mole per dm cube diluted cell. Now this amount they are asking us of hydrochloric acid. What are the parameters we're given? Okay, so in question number 1, This is 40 cm cube. So the volume is 40.0 centimeter cube. And of course, this is the molar concentration. So molar concentration, which is the same as molarity, 0.4 mole per dm cube. And they are asking us to calculate the amount of hydrochloric acid. So it could be that they are asking us for the number of moles of this HCl. How do you calculate the number of moles? The formula I gave you earlier, the first equation is number of mole equals mass over molar mass. And the second one is number of mole equals molar concentration times volume. Now we have molar concentration, we have volume. And then we can use that second equation, which is N equals CV. That is number of moles equals molar concentration times volume. You remember the volume is in dm cube, so you are going to have to convert this to dm cube. How do you convert it? You divide it by 1000. So our volume will be 40 divided by 1000. That will be 0.04 dm cube. 0.04 dm cube. Yeah. Now, so from N equals CV, they are asking us to find N. Just multiply your C by V. So your C is what? 0.4 multiplied by 0.04. So if we multiply it, what is it going to give to us? Whatever we get, that is the moles. But if they now ask you for the mass, but here they are not asking you for the mass. If they were asking for the mass, they would have said, what is the mass? Okay, so the amount is the mole. So let's try to multiply this. If we multiply this, this is 4 times 10 raised to power minus 1 multiplied by 4 times 10 raised to power minus 2. That's going to be 16 times 10 raised to power minus 3, which is the same to 1.6 times 10 raised to power minus 2, which I can rewrite as 0.01612. Okay, so the answer is going to be 0.016 mole, right? 0.016 mole of HCl. That is the answer. Second question says calculate the volume of oxygen. So number 2, we are looking for volume of oxygen that would be required for the complete combustion of 2.5 moles of ethanol. So number of moles of ethanol is 2.5 moles of ethanol at STP. So the first thing you want to do is, this is a combustion reaction, complete combustion. So what's combustion reaction? Combustion is the burning in the presence of oxygen. So when an hydrocarbon or an organic compound burns in the presence of oxygen, the outcome is going to be carbon dioxide and water. Take note of that. So this is organic chemistry in stoichiometry. All right, so look at it. This is what's the formula for ethanol? C2H5OH. They are burning it in the presence of oxygen, and the outcome will be CO2 plus H2O. So now we will have to balance the equation. How do we balance this equation? So let's try to balance. Carbon is 2 here. If I put 2 here, and then hydrogen is 6 here, I have 2. If I put 3 here, hydrogen is 6 here, hydrogen is 6 here. Oxygen is how many here? We'll have to now count. But carbon is 2, hydrogen is 6, hydrogen is 6. So oxygen here, and then I will balance it on this side. Oxygen here is 2 times 2, 4 plus 3. That is 7. 7 oxygen. Now I need to have 7 here. Out of the 7, this is 1. So I need 6 more. So I'm going to put 3 here. So 3 times 2, this is 6 plus 1 oxygen, 7. Oxygen here is 4 plus 3, 7. Carbon is 2, hydrogen is 5 plus 1, 6. Hydrogen here is 3 times 2, 6. So from this balanced equation, 1 mole of this requires 3 moles of this oxygen to give 2 moles of this and 3 moles of this. But the question says calculate the volume of oxygen that will be required for the complete combustion of 2.5 moles. So we have 2.5 moles of ethanol. They are asking us the volume of oxygen. So this amount of oxygen. So from this balanced equation, 1 mole of this requires 3 moles of oxygen. So my 2.5 moles is going to require X moles. So how do we do that? Look at it again. 1 mole from the balanced equation, 1 mole of ethanol requires 3 moles of oxygen gas. So when we now have 2.5 moles of ethanol, how many moles of oxygen do I have? You are going to add 3x moles. You cross multiply. So 2.5 times 3 equals to 1 times x. So our x is going to be 2.5 times 3 is 7.5 moles. So the amount of moles of oxygen that will be required for this reaction is 7.5 moles. But the question is asking us for the volume. Now, if you look at equation 5 from the equation I gave, 1 mole of any gas occupies 22.4 dm³ by volume at STP. So if that is the case, you will now say 7.5 moles, we have x dm³. Then you cross multiply. They've even stated molar volume at STP is 22.4 dm³. So you just say 1 mole of a gas is equals to 22.4 dm³. 7.5 moles will be x. When you cross multiply, your x is going to be 7.5 times 22.4. And that is going to give us, they have 168 dm³. That means the volume of oxygen gas that will be required to completely burn out this or to complete this combustion reaction is 168 dm³. If they ask you to convert to cm³, you multiply by 1000, that would be 168,000 centimeter cube. So I hope that is very clear. So I wouldn't want this video to be too long, so I'm going to stop at this point. I've been able to treat stoichiometry. I've also treated electrolysis extensively. So in the part 2 of this video, I'll be doing acid, bases, and salt. I'll do periodicity, and I will also do solubility. If you have gotten value from this video, please do well to share with your friends and your colleagues. And if you have not subscribed to this channel, please do well to subscribe and go to the comment section right now and type value if you got value from this class. Thank you. I wish you success in your exams. Bye for now.